Hi guys, today I'm going to introduce you what is machine learning. These are my presentation content. What is machine learning? What are the different applications of machine learning, or different types of machine learning, and how to build a machine learning system or model, then various kinds of algorithms. And later on in this series, we are going to take hands-on case studies or doing programming for various kinds of algorithms. So what is machine learning? So machine learning is nothing but simply learning from the data. So it's a subfield of artificial intelligence which has empowered various smarter applications today. So whenever you have a data, then you want to get insight from that. So data science or data analytics is nothing but getting insight from the data. And when you have a data in machine learning terminology, we say it's a training data, and we'll call that as an experience. So from that past data, the machine has to learn, the program has to learn. So the main function of machine learning is construction and study of systems which can learn from the data. So when you have a data, you can apply some machine learning algorithm, and once the algorithm is applied, the outcome is the model. The model is built, and that model can be used to make the prediction of future events or future things. So there is a definition which is given by this person, Arthur Samuel. So it's a field of study which gives the computers the ability to learn without being explicitly programmed. It means that without doing any hard coding, you can simply use existing algorithms and you can build a model. So this is quite mathematical definition. A computer program is said to learn from an experience E. Here experience E means the past data with respect to some task, means some problem statement, and we measure the performance, which is denoted by P. And if its performance improved within an experience or within an environment, we can say that machine has learned or the program has learned. So one simple definition I can say is machine learning is nothing but learning from data. Then what are the applications? So nowadays, so machine learning is being applicable in almost all the scenarios and all the domains. So one of the application I would like to take is speech recognition. So we have very smarter applications today like Siri, Cortana, Google now. So even small kid also searching in YouTube. So he just speak out and his voice is processed, and finally is getting the relevant video or relevant content. So by applying machine learning algorithms, you can also build a speech recognition system or application. And effective web search means machine learning can be used in building web search systems. So one of the algorithm is naive Bayes, which is very good in processing the text. So you can build a web search system by using machine learning algorithms. And in building recommendation systems, we can also use machine learning. So recommendation system is like it will recommend you, for example, whether to go with a particular product or not, yes or no kind of outcome. And in computer vision also, we can use machine learning. So nowadays the technology has been growing a lot, and without AI, so we cannot have smarter things. So computer vision is an extension of artificial intelligence. So it's a field where you know where you can understand what is there in the image or in the video. Simply we can say improving the vision power. So you can understand what is there in the image. So what are the different kinds of objects present in the image. So this is all about the computer vision. So here also here you can use machine learning algorithms and some deep learning based or neural network based algorithms and neural networks, so that you can build a very intelligent application. And in information retrieval, you can use machine learning. For example, IR, information retrieval system. Here, you can access and process millions of documents. For example, whenever you search something in Google, so you expect the relevant document which presents the important information. So only the relevant documents or content must be presented before you. That means the Google has to validate the documents. The Google has to quantify the information which is to be presented to you. So in developing such systems, you can use machine learning, and in detecting the fraudulent activities, so you can also apply machine learning algorithms. So nowadays, wherever you can see most of the fraudulent activities in the internet, so you can also build an application which can identify such malicious activities. So here I took a couple of applications, but there are many applications. Wherever there is a data, you can build a machine learning model to do the predictive analysis. Then what are the different types of machine learning? So importantly, we can classify the machine learning into three types: supervised machine learning, unsupervised machine learning, and reinforcement machine learning. Supervised means what is to be predicted is already known. In the training data, you can have a column which is giving you the outcome. So a model is learned from the training data, and the model already knows what is to be predicted, what is the outcome. Unsupervised means unknown label. Okay, the target variable is not there. In that case, you can explore the structure of data to extract the meaningful information. And next is a reinforcement learning. So there is an agent. Agent means the learner. So he is performing continuous activities within the environment, and by performing continuous activities, the performance can be improved, and then there can be a reward point. And also the point to be noted is there can be also a penalty. So there are three types of machine learning techniques: supervised, unsupervised, and reinforcement learning. So later on we'll explore different kinds of examples and what are the algorithms which falls into these types of techniques. So if you get into details, what is supervised machine learning? So a model is learned from the labeled training data. So data is labeled. So here supervised means we know the correct or desired outcome. The label is already known, so that's why it is known as supervised machine learning. And there are two types under this. Classification. Classification means you can predict a class label. You need to observe the target variable or label, and if it is categorical type, means string type or object type, you can go for classification. For example, you can classify an email as spam or not spam. Regression means if the target variable is continuous type, then you need to apply regression algorithm. So continuous data type means which has some range, like salary. So it has a range, it has a scale, like age. Age is also continuous data because you have the values in which falls between the 0 to 100. Like, so temperature is also regression continuous data type. So when your target variable is continuous, you can apply regression algorithm. When your target variable is categorical type, you can apply classification. And it is very important to understand this figure. So at first you are having a training data, and that data might be having labels or not. If it is a label, if the data is having the label, you go for supervised machine learning. And again, in supervised we have two types: classification and regression. Based on the data type, you have to choose classification or regression. So on it training data, you can apply algorithm. So once the algorithm is applied, the model is built, and we call that model as predictive model. And if you give some new data or unknown data, then model will make the prediction. So this is what all you are doing in the machine learning. And again, if you get into details, what is classification? So classification means predict the categorical label based on the past observations. So the labels are discrete and unordered. Like for example, you have an email spam or not spam. So we'll say it's a binary classification. Classification can also be multi-class. Like for example, digit recognition. Digits means we have totally 0 to 9, 10 digits. So we can say 10 class problem. Letter recognition. So there are 26 letters. So that is multi-class classification. And here you need to segregate the data. You need to separate the data into positive class and negative class. For example, the email is spam or not spam. So it's a binary classification. Regression means you have a continuous target variable, and if you can fit that data onto the line, that will call it as a regression line. So regression analysis means importantly finding the relationship between the variables. So when you have a data set, there can be set of variables. So how the target variable is correlated with other variables. For example, uh, finding the relationship between the number of hours studied and final grade. So what kind of relation is there? So there is a positive relation. So positive relation means if x increases, then y also increase, right? Like if x increases, then y also increase. So this is positive relation. Negative means if x increases, then y decreases. Okay, so this is the line coming towards the downside. So this is negative. This is negative and this is positive. Means if x increases, y value increases. For example, here number of hours increased, then the grade could also be increased. And sometimes there is no relation. Sometimes there is no relation. In that case, you can have a straight line. That means increase of x doesn't increase the value of y. So this is about mm, the relationships. You have the relationship between the variables. So later on we can take a case study, so how to build a linear regression model. And then here so what is unsupervised machine learning? Okay, what is unsupervised machine learning? So unsupervised machine learning means, as I've told you, the data is unlabeled. The target variable is not available. So in that case, you can go for unsupervised. The example for this is clustering analysis or some dimensionality reduction. In clustering analysis, what happens is you can group the relevant objects. You can group the relevant objects based on the similarity. For example, here these objects are together because they have common features. And here also these objects are having similarity, so that's why they are together in one group. Here also the same. So here we can say we have three clusters here, and and the object of one cluster is dissimilar with the object of another cluster because they don't have similarity. So one example for this is distinguish the different types of customers. So customers are all or not equal, right? In that case, you can segregate the customers into different clusters. For example, if you are the manager of the bank and you would like to take a decision, the loan is to be given to whom? Let's say you have got 100 applications. In that case, so you cannot go through the applications individually. So that's a very tedious task. So in order to avoid this problem, so what you can do is you can do the clustering. You can segment the customers or loan applications into different clusters. Like we can segment into 3 clusters. So one cluster is the applicants who are having low income, then another cluster could be middle income, then high income. And then for the customers who are having high income, for them you can apply different trick or different criteria. Similarly, the customers having middle income, so another criteria. Customers having low income, you can apply some other criteria. So then this task will become very easy. So dimensionality reduction is also the technique which falls under the unsupervised machine learning. So dimensionality reduction means reducing the dimensions. Let's say here you have 3-dimensional image. You can reduce the dimension to 2. So 3D to 2-dimensional for simplicity. And importantly, in machine learning, what happens is, let's say you have 100 columns in a data set. So all those 100 columns may not be affecting the target variable. In that case, you can reduce the dimensions. So that is called as dimensionality reduction. You can go with only important features, important variables which can affect the target variable. And then reinforcement learning. So reinforcement learning means, as I mentioned before, there is an agent. So agent is the learner. He is performing continuous activities within the environment. And by performing continuous activities within an environment, the state can change. For example, a beginner to intermediate, intermediate to advanced, like that. And there can be reward point, like for example, whenever you play games, when you complete level 1, then you'll be getting some set of points like 5 points or 10 points. Then if you complete the next level, another 10 points are added. So like this, these games also an example of reinforcement learning. So, and finally there can be a reward point. For example, you would like to learn data analytics or data science. So you can opt the course for a couple of months. So you can perform your training within an environment that could be offline environment or online environment. So by performing training for a couple of days or a couple of months, you'll learn all the concepts, and finally you'll be getting a reward point. Reward point is nothing but certification. So you'll be getting a certification that you have successfully completed a data science course. So like that. And there can be also a penalty. Let's say it's not applicable in all the scenarios, but in some scenarios, like for example, you have done some graduation, but you didn't perform well in the exam. In that case, you are going to be failed. So failing is nothing but penalty. You need to reappear in the exam. So this kind of scenario is called as reinforcement learning. So most of the games and robots, intelligent machines, intelligent applications are developed by using reinforcement learning. And here, before you jump into machine learning, I mean practical, so you need to understand some basic terminology here. Your data is two-dimensional, right? You are having rows and columns. The last column is called as class label or target variable. And other than the last column, we call the remaining columns as features, attributes, measurements, or dimensions. And then we call these rows as samples, instances, and observations. So this is one of the very famous dataset, iris dataset. So every machine learning engineer should be having a hands-on experience on this dataset. What is iris dataset and how to build a classification model. So basically this dataset is having four features. So petal length, width, sepal length, width. So based on these four parameters, sepal length, width, petal length, width, you are going to decide what kind of flower is this. So there are three types: setosa, versicolor, and virginica. Means based on the values, you are going to determine the flower is setosa type, versicolor, or virginica. So here you need to understand the terms. So people use different terminologies. So rows are called as features, attributes, measurements, or dimensions. And other than the target variable, the columns are called as samples, instances, or observations. The last column, we'll call it as target variable, sometimes response variable also, if it is the data is continuous type, like this. So these are the terms. You should keep these in your mind. And then how to build a machine learning model. So there is a process, actually we'll call it as a workflow or pipeline. And whenever you have a data, so that data is not clean data, so it's a dirty data, so you need to do data pre-processing. So you have to clean the data. So once the data is clean, you can apply an algorithm. So pre-processing means raw data is ideal for learning, so you can clean it. So that you can also apply other steps like feature scaling. Feature scaling means putting the data in the range. If the data is not scaled, then model is going to not understand your data properly. Let's say some values are very smaller and some values are higher and some values are medium type, so it is not going to understand. Like for example, age is a continuous data, and we know the minimum value is 0 and maximum value is 100. But if I give the input as 120, So is that going to be a valid data? No. So that's why scaling is important. So bringing the values in the fixed range. And encoding. Sometimes we would like to convert the features from numeric to categorical type and categorical to numeric. So categorical feature to numeric is called as encoding, and no machine learning algorithms works with categorical type of data, so you need to encode. So for that we have different kinds of encoding methods. And discretization means sometimes we convert the numeric features into categorical, like for example age values can be converted into the categorical values like younger, senior citizen, right, middle age, like that. And feature selection, so you can select only the important features. And dimensionality reduction also falls under this step, so reducing the dimensions. And once the data is clean, you can apply algorithm. And there are various kinds of algorithms for the specific purpose. For example, classification. So for classification you have a set of algorithms like decision tree, random forest, k nearest neighbors, right? There are many algorithms for classification, so you should know which algorithm is to be applied for your problem statement. And in reality or in practicality, so if you just apply a single algorithm and if you say that your model is best, so nobody is going to trust that. So you have to build set of models, at least 3 models, and then do the comparative analysis. So and then this together is called as workflow of a pipeline. So what I have explained is there in this picture. So at first we are having a data and we split that data into training and validation. Then the data might be having labels or not label. Once the pre-processing is done, then you can apply algorithm. Then once the algorithm is applied, then the model is built. And then if you give new data to the model, then it is going to make predictions. So these techniques falls under the data pre-processing, and these are the techniques which falls under the model evaluation. So once the model is built, you need to evaluate, means how much percent it is accurate. Let's say 90% is the accuracy of the model. Then remaining 10% it can make mistakes. So like this, so you have to evaluate your model. So you will be learning all these things in the future classes. And these are the set of algorithms which are used for classification and regression. So next immediate step is you need to learn these algorithms, and you need to know how to do how to build a classification model, how to build a regression model, and how to do supervised, unsupervised. So next immediate step for you is practically implementing or practically building model. So that I'm going to cover in my future classes. So if you have any questions, you can feel free to comment, and you can also feel free to reach me.